So a parametric equation is an equation that's in terms of a parameter t. T is often used because a lot of times it represents time. And so x is in terms of t and y is in terms of t. And so when you graph this, it's easy. It's just to go ahead and make tables in this case, and you're going to have a t, you're going to have an x and a y. And so you're going to put in convenient t's to get your x and y's. Now you're going from -4 to 4, so you really need to know what these points are from -4 to 4. Putting that in, you're going to get 20 and -3 and 2/3. Putting it in here, you're going to get 20 and, let's see, -2 and 1/3. And then you want to choose a couple other convenient points like 0 and possibly 2, which is, let's see, 8 and 1/3, -2 and 2/3. So you're starting with this point at 20, and you're going, let's see, if this is -3 and -4, -2, I try and exaggerate and spread it out a little bit. The first point is 23 and 2/3, which is going to be down here. And then jumps to 4 at -3, back to 8, 2 and 2/3, and back to 22 and 1/3, which means that this graph is going to look something like this, which is a parabola opening to the right. And so that's sufficient in drawing that graph. Let's go to this one. And again, you're looking at what your domain is for the t's. And so you really want to be smart in plugging numbers in. Of course, you want 0, which is going to be 0, 2. And I'm also thinking about putting other numbers in that make sense. Now, this is a problem because I don't want to use decimals, so I would want to use 1, 1/3, and 3. Also, 4 is a good number, which is 1 1/3 and 4. And my last number I want to choose is 9. Now I notice it's outside, but it's really going to give me a good idea of what this graph looks like because of the way the numbers work out. And so I'm looking at my xy's again. So my first point is 0, 2, 1/3, 3, 1 1/3, 4, and 9, which is way out here, and 5. So this is going to look like this. Now, you have to be a little bit careful out on the end here because it's really going to 8. So what I want to do is put a closed circle at 8, and then I want to disregard the end of that point. And that's going to give me a good idea of what that graph looks like. Now, going down to the bottom of this, it's basically converting between parametric equations and rectangular equations. And the goal here is to eliminate the t in both cases. If I'm looking at the first case, to eliminate the t, I'm going to solve this one for t because it's the easiest and shove it in for t. So that means that y equals t over 6 minus 3. That means y plus 3 times 6 equals t. So my x is equal to 6 times y plus 3 in parentheses, and it says that it's squared. So I'm going to square the whole thing plus 4. And you would go ahead and expand that and get your equation. Let's take a look at the second one. I'm going to focus on solving for t. The first case is going to be the easiest one. So I know that t is equal to 3x, and then I'm going to simply substitute that in to the second one, 3x plus 2, and now you eliminated the t. Now, one other part of this is you have these restricted t's. Now, what you could do is figure out what your minimum x would be, or your domain of your x's, and then include that in here for the domain. But in terms of what I'm concerned about, generally switching the equation by using substitution is sufficient.